whatever the data is stored in the undo segment, the copy of the table present in the undo segment will be removed. The table, the changes whatever is applied on the table, it was present in the temp, that is buffer. It is moved to database now, which became permanent. Since data is committed, all other users also can see the new data now. There is no copy of table in the undo segment because of commit. The table stored in the undo segment will be removed. The data whatever is present in the buffer will be committed, will be moved to database, and then it will be saved. Once it is committed, data is visible to all other users, not only for the current user. That is why, including Scott, U1, U2, U3, everyone is able to see the new data, which is 900 now. So once it is committed, everybody can see the same data. If it is not committed, the user who has modified can see the new data, rest all other users connected to the same database can see the older data. So it is clear that how other users can see old data and current user can see the new data. Now let us see the lock. Let us execute the same update statement what we have performed earlier. Update scott.emp1 set salary equal to 900 where enum equal to 7499, or instead of 900 we make it as 800 because it is already 900, so we are making it as 800. Now we have updated by this Scott schema. Scott has updated the salary of employee number 7499 to 800 from the existing value 900. So now if Scott selects data, he can see 800. Other users can see 900. Now Scott has updated this table, this record of 7499, column of salary. Now U1 wanted to update the same table, same column and same row. If he performs this update by U1, what will happen now? Because this record is already updated by Scott user, the record has locked by Scott, means a lock is placed automatically by the database server for the user Scott. Only Scott can read and perform read and write operations on this particular row. Other users cannot perform any write operations on this particular row because there is a lock. Until this lock is released, other users cannot place a lock on that. At any point of time, one row can have only one lock by one user. This is implicit lock. If it is row level or implicit lock, only one lock can be placed implicitly by the database server for one user, not by multiple users. So now if we try to update the salary of 7499 of EMP1 table by U1, he cannot succeed. He will go for waiting. He will be placed in the queue. He will be waiting now. How long he will wait? Until the lock is released by Scott. Scott has placed a lock on this. He is doing some process over there. Once Scott has completed his task and perform a commit, then lock will be released on that particular row. How the lock will be released once it is placed? Locks can be released by using commit or rollback. This commit or rollback can be implicit or explicit, either implicitly by the database server or explicitly by the users. So because of commit and rollback only, the locks can be released. So as of now, a lock is placed for Scott schema on this particular row. So Scott is in first person in the queue. Behind that, U1 is there now. U1 is trying to access the lock. Since he is unable to access the lock or place the lock on this record, he cannot succeed the update operation or write operation. He will be waiting enormously. Means till the lock is released by Scott user. Till that time, he will be in the queue. And there is no way to come out of this wait event by U1. The only option is kill the session or ask DBA to remove the lock on this or to kill his session. Without killing the session, there is no way to get rid of this wait event. See now, U1, neither he is completing this particular statement nor he cannot do anything till the lock is released. He cannot execute even any other statement. It is in hanging state. The system is kind of hanging state now. He cannot perform any other operation till the lock is released. So either by mistake or wantedly he entered into the queue of waiting event. Because of that reason, he cannot perform any other operation. See, Scott, he is able to type U2, he can type something. U3, he can type something. But when it comes to U1, we cannot type anything. He cannot perform any other operation till this particular operation is completed. So now U1 is standing in the queue to acquire a lock on the particular record of employee number 7499. Not only the salary, since he is updating the salary column, not only the salary column will be locked, the entire row will be locked. Next, now let us perform update of EMP1 salary equal to 800 where employee number equal to 7499. For the same employee, same column we are updating in the same table by U2. User 2 is executing now. Let us see what will happen. He also entered into wait event now, but he is standing behind U1. See, now he is also not able to do any other operation. He is in a hanging state now. Now let us see in U3. Update operation, same table, EMP1, same column, salary, same employee number 7499. He also entered into wait event now. He is not able to type anything. So all are standing in queue. Scott has placed lock on this record 7499. He has successfully completed his update operation. After that, he is able to select, he is able to type something, he can do anything. After that, U1 tried to update the same record of 7499. By mistake, he entered into wait event. He is standing in the first place after Scott. After that, U2 tried to update the same record. So he also entered into wait event. He is standing in the second place after U1. Next, U3 also tried to execute the update operation on the same record 7499. He also standing in the queue now. He is in the third position, that is first U1, next U2, next U3. Scott is in the starting position like 0. He is able to do anything. He can perform anything also here. Now all the three users U1, U2, U3 all are in waiting state. They are waiting to get the lock on this particular record of 7499. They are unable to get the lock because a lock is already placed on this record by Scott. Unless the Scott has released this lock, other people cannot access the lock. Now let us release the lock by Scott. How can he release the lock? By using commit or rollback. We will say commit. When Scott is committed, lock will be released. As soon as lock is released by Scott, immediately the next person, whoever is waiting for acquiring lock on this record, will be getting the lock. Once the person gets a lock, then he can successfully complete his write operation. Who will get the lock now? U1, U2, U3. Whether all the three people will get lock or only one person get lock. Multiple locks by multiple users is not possible in case of implicit locking or row level locking. Only one user can place lock on one record at a time. So when the lock is released by Scott, in this case, the person who is waiting in the first place in the queue will get the lock. That means the moment Scott presses enter, the person who is standing behind Scott is U1. U1 will get the lock and then his update operation will be succeeded. Let us observe closely on the monitor. The moment I press enter, commit will be completed in the Scott schema. Lock will be placed by the U1 and the update operation will be completed. So you will get one row updated automatically when we press enter in Scott schema. Let us observe here. Now I am in the Scott. I am pressing enter. See, the moment we press enter here, U1 has got the lock and one row updated. Lock is released by Scott. So the person who is waiting immediately after Scott is U1. He will get the lock immediately. Once he get the lock, the write operation whatever he is planning to perform will be completed. Now U1 is holding the lock. U2 and U3 are still waiting in the queue. So still we are not able to type anything in U1, U2 and U3, but U1 we are able to do something. Scott is free. We can type anything here. U2 and U3 are still waiting in the queue. Now let us place a commit in the U1. The moment we press enter here, the person who is standing next to U1 is U2. He will get the lock and his update will be succeeded. Observe closely in the U2. When we press enter here, automatically U2's operation will be completed. Observe in this session, that is the third one, which is U2. Closely, I am going to press enter now. See, when I press enter here, commit completed. That means lock is released. Immediately the person who is waiting for this lock after U1 is U2. So he got the lock and his write operation is successfully completed. Now he is able to type something. Still U3 is in waiting state. We know that lock can be released because of either commit or rollback. As of now we have released lock from Scott and U1 because of commit. Now let us use rollback. Due to rollback also lock will be released. We are performing a rollback here. The moment we press enter, lock will be released by U2. U3 will get the lock and U3's update operation will be completed. This is what we have typed earlier. So that is coming. See, here we performed rollback complete. Because of this, lock will be released. Once the lock is released, the person who is waiting behind him is U3. He got the lock and he has successfully completed his write operation. So before any write operation, automatically a lock must be placed on that particular row or group of rows that are going to be modified because of our write operation. Once the lock is placed, then only we can perform the write operation on that particular group of records or single record. So that we have seen practically now, how they will be waiting when multiple users are trying to perform write operation on the same record, how they will be waiting in the queue, how long they will be waiting in the queue. They will be waiting in the queue till the lock is released. So there is no other way to come. Once we step into the queue of waiting state, there is no way to come out of the queue and to execute some other operation. The only option is ask the DBA to kill our session. That means our SQL session will be closed, a new SQL session has to be opened. Until that, we cannot do anything over there. We cannot even disconnect from that session, connect it to new session. So still the lock is placed by U3. So to release that lock, we need to perform commit or rollback. So now locks are released. This record is completely lock free now. That is what we have seen here from 4 sessions. This is about row level locks or implicit locks, or we can also say DML locks. The locks will be placed because of insert, update, delete and merge. See, as of now we have seen because of update. Not only because of update, a lock will be placed automatically by insert. The record which is inserted is logged for that particular user. Other users cannot see that record until it is committed. Only current user can see that record. Rest all other users cannot see this newly inserted record. Delete. Once we perform the delete operation, we delete all the records from the table. Current user can see no rows, but all other users can see all the records. Let us see that. Insert into EMP1 values 1, A, 100, 10. One record inserted. Select star from Scott.emp1. Scott is the owner name. We have 5 rows here. Let us select from other users. Rest all other users can see only 4 rows. I think we did not set the environment variables in other sessions. Okay, now 4 rows are displayed in all the schemas, but in Scott it is displaying 5 records. We do a commit, execute, the select statement here, it has 5 records. Since it is committed, everybody can see the 5 rows. Before commit, Scott was able to access the data from the database or from the buffer. All other users were able to select the data from the undo segment, which was having the old copy of the data from the table, that is 4 records. Now let us perform delete. Not only Scott, we can delete from, I think other users doesn't have delete operation, so I will delete from here only. Delete from emp1. 5 rows deleted. If we select, Scott can see no rows selected, but other users can still see the 5 records because data is not committed. Because of delete, the copy of the existing table will be copied into undo segment. So all other users are accessing the data from this table from the undo segment. Current user is accessing from the database or buffer. That is why current user is not able to see any data. Rest all other users are still able to see the data because they are accessing from the undo segment. So we don't want to commit now. We will do rollback. Because of rollback, the current user also can see, everybody else can see the same rows, 5 rows now. So now we have seen insert, update, delete. These are the 3 write operations because of which a lock will be placed and data will be copied to undo segment. Current user can access the data from the buffer or database. All other users will be accessing the data from the undo segment. That is why current user can see the new or modified data. Rest all other users can see the old existing data from the table. And before write operation, a lock will be placed automatically by the database server on that particular record. Means the records that are going to be modified because of our write operation, and all those records lock will be placed. These are DML locks or implicit locks which are placed automatically by the database server. Now we will see the explicit locks where user can have the control. User can place the lock explicitly. These are called table level locks. The explicit locks can be placed at table level, means on the entire table, not on a single record or a group of records. On the complete table we can place a lock. That is why these are table level locks. On table level locks, the users can take the control, can have the control. We can place the lock. We can take the control which type of lock to be placed on that. Now let us see the table locks. We know that the locks will be placed on the tables, on the entire table. Now when it comes to the table level locks, the modes available are these 6 options: share mode, row share mode, share update mode, exclusive mode, row exclusive mode, share row exclusive mode. So actually row share and share both are same. Here row is optional. We can say simply share or row share. So they are single. Next, share update is one mode of lock, and then exclusive mode, row exclusive mode, share row exclusive mode, all these are same. Exclusive mode, row exclusive mode, share row exclusive mode. Share is optional, share row is also optional, exclusive is mandatory. So basically there are three different modes of logs. For the first mode, share mode, we have two options, share or row share. Share update, we have only one option. The third mode is exclusive mode. Here it is either exclusive, row exclusive, share row exclusive. Three options are available here. Now let us see how to use these modes of logs at table level. Yeah, table level logs, these are explicit logs. Log table, table name in row share mode. Share spelling is wrong, that is why it is throwing error. It is giving valid modes or these things. This is the meaningful, 100% meaningful message where we get all the different modes of logs available in that particular version. Log table, table name in share mode or row share mode, both are same. Share mode or row share mode. Multiple users can place the logs on the same table at the same time in share mode. Multiple users can place logs. Next, share update mode. Log table, table name in share update mode. This type of log also can be placed by multiple users at the same time on the same table. Exclusive mode. Log table, table name in exclusive mode. Only one user can place the log in exclusive mode on one table at a time. So exclusive log mode is only one at any point of time on a single table by one user only. Multiple users cannot place the logs on the same table in exclusive mode at the same time. Only one user can place an exclusive log on a table at any point of time. See, only one user can place. See here, first we placed share mode, again row share mode. Possible. Allowed. Row update mode, share update mode, allowed. EMP1, exclusive mode, allowed first time. Row exclusive mode, both are same, allowed. Share row exclusive mode, it is also allowed. This is mistake here. Exclusive mode, row exclusive mode, share row exclusive mode. Only one user can place a lock at a time. Share exclusive mode is invalid option. Row share exclusive mode is also invalid option. The only option valid option is share row exclusive. If you reverse the words row share exclusive, even though all the keywords are there, it's not the valid lock mode. Row share exclusive is invalid. Share row exclusive is valid. So we have to be see, whenever we want to use this option, we can simply use exclusive mode. Otherwise, we have to be very careful if you are using share row exclusive mode like this. Row is optional, share is also optional. We can simply use exclusive. If you want to use all the words, then the order should be share row exclusive. If we use row share exclusive, it will throw error. Once we perform rollback or commit, lock will be released. Even though it is explicit lock, this lock also can be released by using commit or rollback. This can be implicit or explicit. So whatever the type of lock it is, either DML lock or table lock, row level lock, table level lock, because of commit or rollback, lock will be released automatically. We can add or append no wait clause for the lock statement. So normally, suppose we wanted to place a lock on a table. For exclusive mode, it is not applicable. It is applicable for other modes. When we want to place a lock on a table, we issue lock table name in some XYZ mode. If this particular table is already locked by some other user, then our lock statement will go for waiting in the queue. Neither it will come out nor it will not allow us to do any other task. It will go in the hanging state like what we have seen in earlier case. Instead of that, suppose if we do not want to stand in the queue or wait till the lock is released, in that case we can use no wait clause at the end. That means if the table is already locked, do not wait in the queue. Return the control to the calling environment so that